All are welcome to this video. In this video, I am going to discuss about Geographic Information System and its overview, timeline, history, life cycle, principles, importance, applications, advantages, challenges, best practices and future trends. GIS plays a crucial role in map-making process in the form of digital flatform. A geographic information system is a computerized mechanism that allows us to capture, store, display, query, analyze, and visualize data related to geographic locations. Now GIS is commonly used tool for find location, map preparation, navigation, calculating distances, and many more requirements all over the world. What is Geographic Information System? Geography is the study of land, inhabitants, and features on the Earth. Information will provide details of the features of Earth. The system is the technology and method used to capture the objects on the Earth's surface. A geographic information system is a computerized mechanism that allows us to capture, store, display, query, analyze, and visualize data related to geographic locations. Timeline of Geographic Information System. This diagram illustrated timeline of Geographic Information System evolution from 1960 to present in various technological development phases. Mainly, it divided into Introduction to Geographic Information System phase 1960 to 1975, Experimental phase 1975 to 1980, Commercial phase 1980 to 1990, and Globalization phase 1990, present. I think this timeline very useful for better understanding about GIS development. History of Geographic Information System. The early history of GIS. The field of geographic information systems started in the 1960s as computers and early concepts of quantitative and computational geography emerged. Early GIS work included important research by the academic community. The first GIS. Roger Tomlinson's pioneering work to initiate, plan, and develop the Canada Geographic Information System resulted in the first computerized GIS in the world in 1963. The Harvard Laboratory. While at Northwestern University in 1964, Howard Fisher created one of the first computer mapping software programs known as SMAP. In 1965, he established the Harvard Laboratory for Computer Graphics. ESRI is founded. In 1969, Jack Dangermond, a member of the Harvard Lab, and his wife Laura founded Environmental Systems Research Institute Incorporated, ESRI. The consulting firm applied computer mapping and spatial analysis. GIS goes commercial. In need of analyzing an increasing number of projects more effectively, ESRI developed ARC/Info, the first commercial GIS product. GIS today. GIS gives people the ability to create their own digital map layers to help solve real-world problems. How Geographic Information System works. A geographic information system works by integrating geographic data with descriptive information to create maps and analyze spatial relationships. It allows users to visualize, analyze, and interpret data in a spatial context, revealing patterns, relationships, and trends that would be difficult to discern from tabular data alone. Components of Geographic Information System. A working GIS integrates 5 key components: hardware, software, data, people, and methods. Hardware. Hardware is the computer, servers to desktop, on which a GIS operates. Software. GIS software provides the functions and tools needed to store, analyze, and display geographic information. Data. Possibly the most important component of a GIS is the data. A GIS will integrate spatial data with attribute data with the help of DBMS. People. GIS technology is of limited value without the people who manage the system and develop plans for applying it to real-world problems. Methods. A successful GIS operates according to a well-designed plan and business rules, which are the models and operating practices unique to each organization. Purpose of Geographic Information System. The primary purpose of a geographic information system is to capture, store, analyze, manage, and display all forms of geographically referenced information. Essentially, it links data to locations, revealing trends and relationships hidden within that data. This allows for informed decision-making across various sectors, from urban planning to environmental management, emergency response, etc. Data capturing method in Geographic Information System. Data capturing methods in GIS. Main spatial data capturing method for GIS can be classified as shown below. Photogrammetry, remote sensing, land surveying, GPS, old plan scanning and digitizing cadastral land parcel data. Attribute data capturing method. Text data entered to DBMS, tabular data converted to DBMS. How to represent geographic information. Raster and vector are two fundamental ways to represent spatial data in geographic information systems. Raster data uses a grid of pixels, each with a value. Vector data uses points, lines, and polygons to represent features. Vector data is generally better for representing discrete features with clear boundaries, while raster is more suitable for continuous data like satellite imagery or elevation models. Vector data, raster data analysis. Raster data having following characteristics. Makeup of pixels. Continuous data. Represents data in cells or grid. Larger file size. Egg. Elevation map or slope map. Vector data having following characteristics. Made of series of x, y coordinates. Discrete data. Represent data using vertices. Smaller file size. Egg. Point, line and polygon. Vector data, geometry. Vector data geometry mainly divided into four categories. Point feature, features like manhole, electric post, telephone post, etc. Line, polyline feature, features like fence, wall, footpath, railway line, road, etc. Area feature, features like garden, paddy, building, ponds, lakes, etc. Text, attributes name like Palumbo, Mahali River, Nuariwewa, etc. Spatial data representation. Point features with coordinates, x, y, z. Line features with a collection of coordinate pairs, which have starting point and end point, have length but not area. Area polygon features have both length and area. Vector data, 3D. 3D vector data can be created combining with DEM and orthophotograph. Digital elevation/terrain model, DEM. NASA's data for digital elevation models, DEM, comes from airborne and space-based sources and are useful for analyzing a majority of Earth's terrain. An orthophotograph, also known as an orthoimage, is an aerial photograph that has been geometrically corrected to remove distortions caused by camera angle and terrain elevation. Building a geographic information system, implementation strategy. Requirements phase. User needs establish a foundation for completing the design. User location and peak business loads establish a foundation for system architecture design. Design phase. Infrastructure upgrade requirements must be identified to determine deployment costs. Network communication capacity is an important consideration for GIS deployments. Hardware and software procurement requirements must be identified. Software development requirements and data acquisition needs must be identified. Building a geographic information system, implementation strategy. Construction phase. System procurement authorization, based on the design budget and deployment timeline. Data acquisition and database design efforts begin. Procurement authorization for application design and development. Prototype testing plans completed and scheduled to validate product delivery within design performance targets. Implementation phase. Initial deployment and operational testing. Final system delivery, user training, and workflow migration complete. System maintenance operations. Application of Geographic Information System. GIS application in agriculture. GIS helps with crop yield maximization by optimizing planting patterns, optimizing irrigation schedules, and helping farmers predict market prices. Some GIS analysis is also being applied to the use of pest-resistant crops and their effect on land conservation. GIS in urban planning and management. GIS has applications in urban planning and management. By analyzing various features of cities, GIS can help planners to make better decisions about how to manage inputs like natural resources or traffic. GIS for tourism. GIS can help with tourism promotions, better market offerings, improved customer service, a better understanding of the business performance and the location-related impacts of decisions. Application of Geographic Information System. Application of GIS and land use. Land use mapping mainly includes the three broad categories: agricultural land uses, residential land uses, and commercial/industrial land uses. A GIS can be used to map these types of land use by overlaying them on the base map. Application of GIS and mapping. With the advancement in technology and increase in computing power, geospatial technologies have become more widespread these days. It is now easier than ever before to create your own custom map with all kinds of features like routing through GPS coordinates or street view with 3D buildings. Uses of GIS in navigations. GIS is also used in navigation applications when it comes to making sure that people are able to find their way around a city or country. It can be used for any number of reasons, including getting directions, locating businesses or points of interest, and plotting routes. Advantages of Geographic Information System. Some of the main advantages of GIS can be described as shown below. GIS allows us to view, understand, question, interpret, and visualize data in many ways that reveal relationships, patterns, and trends in the form of maps, globes, reports, and charts. A GIS helps you answer questions and solve problems by looking at your data in a way that is quickly understood and easily shared. GIS technology can be integrated into any enterprise information system framework. Challenges of Geographic Information System. Geographic information systems face several key challenges can impact the accuracy and efficiency of spatial analysis and decision-making. Inconsistent data. Geographic data comes from diverse sources: satellite imagery, GPS, surveys, with varying formats, scales, and accuracy, making integration difficult. Hardware and software. Ensuring appropriate technology, quality hardware and software, and adequate funding are also ongoing challenges. Specialized knowledge. GIS requires specialized expertise and interdisciplinary collaboration, which can be a barrier to implementation. Cost. The high cost of GIS technology, software, and data can be a barrier to adoption, particularly for smaller organizations. Standardization. Variations in how elements are represented on a map and different systems using different icons can create inconsistencies. Best practices of Geographic Information System. Best practices for Geographic Information Systems, GIS, involve focusing on data quality, efficient workflows, robust security, and clear communication. Prioritizing data accuracy, standardization, and proper documentation ensures reliable analysis and informed decision-making. Data quality. Ensure accuracy, completeness, and consistency of spatial data. Implement data validation rules and automate quality checks. Data standardization. Use consistent data formats and projection systems to facilitate interoperability and analysis. Data backup and recovery. Implement robust backup procedures to protect against data loss and ensure business continuity. Clear objectives. Define specific goals and objectives for each GIS project to guide the analysis process. Automated processes. Leverage automation to streamline tasks, improve efficiency, and reduce errors. Future trends in Geographic Information System. Future trends in GIS mainly based on 3D visualization, 3D analysis, AI and machine learning techniques. Data models will be developed to handle 3D and time characteristics, and complex interactions between objects. Support for quality assurance and quality control. Support for multimedia will become common. GIS and GPS will be integrated for data collection and compilation. Tools for visualizing 3D and time-dependent data will be developed. Sector-specific products will be developed to cater need of the clients. This is end of presentation. I think you have got better understanding about Geographical Information System and its overview, timeline, history, life cycle, principles, importance, challenges, best practices and future trends for find location, map making, distance calculation, various kind of map preparing to fulfill client's requirement. If you like this video, please press subscribe button and many more educational and technical video you can see in the future. Thank you very much your attention.